one, which is interface circuits of our lab 4. So basically, our circuit is implemented using the diagram here, where we have a dip switch. We use 3 switches and 1, 2, 3, 4, 5, 6 LEDs. So basically, how we program it is we are using the benefits of these components which have reverse and forward bias, which will be explained later. So based on this, we calculated our resistor to be 61.11, where since due to limited sources, we can only use 82 ohms. So moving to our table here, this is our expected output, the one we set and based on the readings. So with our input, you can see that we start from binary of 0 to 8. So basically there will be 8 different type of combination. The 3 here represents an open source, means no current flowing through, and 1 is high output and 0 is no input, no output at all. So based on this, the first combination and the last combination would display nothing at all. So moving on, for our input, we will be using port C pin 5 to 7 and port A pin 2, 12 and 13. So moving on to our codes, as we can see here. So first, we have already defined our output to 12, 13 and the 3 inputs here, which are placed together, so it's clear. And for initialized Charlieplexing, we initialize all the clocks for A and C, and also the marks PE and PS value, including the input, which is different. Now moving on would be set LED. This is where we achieve the display we wanted through the results, where we set, as we can see here, since the first one expected all to be closed, so from PDDR, we set all to input, so there will be no output at all. So to compare it with the rest, we will have LED number 1, where we set both as an output and 1 input, and set and clear port pin 2 and set low pin 3. So the rest will be based on the combination of the table here up to the LED number 6. So now, talking about the read input function, it's basically to calculate the input being placed inside our circuit, and with that value, we will check which function is to be activated in the set LED part. So basically, that's the end of this part. Moving on to our circuit here, back to the input main. So basically, we just initialize the Charlieplexing and use a forever loop to get the input and set LED. That's all. So moving on to the circuit, as we can see here, all of the 3 input is currently at 0. So as expected, none of the LED lights up. So it's expected that this LED will light up when I input the value of 1. So as I set it as 1, see, the LED lights up. So the expected LED that is gonna light up is this one when I set the value of 2. See, as we can see here, number 2. So moving on to number 3. Here, 4, 5 and 6. So our 7 will be no LED lights, as we said it earlier. So from there, I did like to end my presentation. Thank you.
Hello, I'm Melvin, and I will be demonstrating part 2A and 2B. First thing first, for the part 2A is actually the assembly version of the set LED. Moving on to the code. Firstly, we set the GPIO address as the 0x400FF000. This is the fixed address for GPIO A, and for the PDOR offset and PDDR offset is also fixed address that we found in the MK20 header. Moving on to the set LED. Firstly we push the link register to the stack and log the R1 equal to the GPIOA we set earlier, and we compare the R0 value that we get from the main function in the part 3 to here to compare whether what is the output. For the first one is compare it with 0, and when the output is equal to 0, and it will branch to 0 and send for the following by changing the compare value to 1, 2, 3, 4, 5, 6, and 7. And here is the 0 part, which we set the PDR as 0, which means all of them as the input, so it will display nothing. And for the 1, we put the value as 2x004 as for the same as the part 1 in the table that shown by Vicky. And here we set the PDR and send for the following. And then after all the thing, it will branch to ends so that it will pop back to the main C function. And for the part 2b, this is the 1 second delay function we use. Basically we're using a loop for this delay, and that's all. Thank you.
My name is Nosuki, and today I will be talking about part 3 of Lab E4, which is talking about the main program. So now moving on to the code. So first of all, we define output 1, 2, 3 based on the port A, port A2, port A12, and port A13. And then we declare the function, the external void function, the external void set LED, external void 1 second delay, and also the void initialize Charlie plexing. Now moving on to the main function. First, we set the counter to 0, and then we call the initialize Charlie plexing function, which is the one below here, which is the clock. First of all, this is the clock, and then we set the high drive strength for port A2, 12, and 13, and also we declare these 3 port A2, 12, and 13 as output. Now moving back to the main function, now we call the external void set LED function and also the 1 second delay function, and according to the loop, the for loop, so when the counter is below 8, the loop will repeat itself, and also there is a 1 second delay for every loop. Now moving on to our circuit. So as you can see, for every loop, it will have a delay of 1 second. So 1, 2, 3, 4, 5, 6, 7, 1, 2, and then 1, 2, 3, 4, 5, 6, 7. Yeah, and so it ends here, and then the loop will keep on repeating itself. So yeah, that's all. Thank you.